Hi, my name is Jennifer Strang and I'd like to welcome you to the GIS Center's Lunchless Learn in QGIS. This session is so you want to make a map, where and how to find data.
Before you begin, it is assumed that you have QGIS loaded on your computer before starting. If you don't have it on, you can go to https://www.qgis.org/download and download and install the appropriate version. Note that this software is available for multiple platforms, be it Windows or Mac. Okay. Note, we will be downloading the data as part of the exercise, but if you have any issues, please check out the link that was emailed to you prior to the session and use that if there's any problems with any of the websites.
What's on the agenda today? Well, we're going to start off by learning what geospatial data is and how it's made. Next, we're going to move on and compare vector GIS versus raster GIS. Next, we're going to go to file formats to make sure we understand what they are and which formats will come in to the various programs. Then we're going to learn a little bit about projections and data sources, where you can find various data and what you should be looking for. What happens if you have questions? Well, feel free to ask questions throughout the session. Just type them in the chat screen. So if it's something general, I'll answer it in the chat screen so everybody can see. If it's something specific to you, I will set up a separate window for you, a private chat window, and we can review it there. Just remember, there is no such thing as stupid questions. Trust me, if ever there was, I'm pretty sure I asked them all. Just remember to be patient. Answering questions online can take a little more time than if we are in person. So just be patient. I will get to you and make sure your questions are answered so that you can continue. What exactly is geospatial data? It's place, an attribute, and optionally time. So essentially it's the locations and descriptions of geographic features. It combines spatial data as well as those other descriptive attributes. This geospatial data, the location data, can be linked with other non-spatial data sets. This can be a wide range of things. Could be physical data, could be environmental, could be social or economic. And remember, it can come from a wide range of levels of measurement. So it can be nominal, it can be ordinal, interval, or ratio. The thing to realize is time is optional, but you'll see that more and more data sets will start to include time as data is getting easier and even cheaper to start collecting, so we can have multiple time slices. So you'll see time becoming more and more relevant in the data sets going forward. Estimates are that 80% of all data has a spatial component. So this is a bit of information I got from Esri, which is the maker of a different GIS called ArcGIS Pro. But that being said, that means that there's a lot of data that can be viewed or visualized in a GIS. So now that we know a little bit about what geospatial data is, how do we get it? How's it collected? Well, there are a number of ways, and we're going to list them here and then go into a little bit more detail. There's survey techniques, there's aerial photography and remote sensing, there's GPS or global positioning systems, there's geocoding and databases, as well as digitizing and scanning. So one of the oldest ways of collecting GIS data is through survey techniques. So in doing this, the location of all of your things that you're positioning is relative. You're using distances and angles from a known location. Typically, these are geodetic control points, and measuring to the position that you want of something else and figuring that out. So these are survey techniques. They tend to be very time consuming, but can be very, very accurate.
Another way to get GIS information is through remote sensing. So what is remote sensing? It's a science of deriving information about the Earth acquired at a distance. So some examples of this are aerial photography, radar, and satellite imagery. So we're looking at a satellite image here. It's collected by the Planet Labs SuperDove satellites. And what it's showing here is the Tantalum fires. You can see the darker green color is the area that has been burnt, whereas the red areas are the areas that have not been burnt. Again, this happened in May of 2023, and basically this information was readily available very quickly, even during the fires while they were taking place.
The next common way of collecting GIS data is through aerial photography. This is typically used for topographic map compilation. So these are going to be what most people consider to be base maps. They contain information about contours, roads, rivers, lakes, and other important features. It's also used for resource inventory. Here in Nova Scotia, it's used for our forest inventory, and it's really good because it collects large areas in a lot of detail. But it does take interpretation to understand what you're looking at and to get it ready to come into a GIS. Another way to collect geographic information is to use GPS or Global Positioning System. So this is a satellite-based navigation system. There's a minimum of 24 orbiting satellites going around the Earth at a time. It was originally intended for the US military, but it was made available to everyone in the 1980s. And the idea is it's going to work in any weather, anywhere on Earth, 24 hours a day. So a bit more information about GPS. The satellites are circling around the Earth twice a day, so these minimum of 24 satellites, which means they're going about 7,000 miles an hour, and they're transmitting information to Earth. GPS receivers use the information that they're collecting to calculate the location. It can be extremely accurate, but for devices like shown in the bottom right corner here, or on your cell phones, usually as close or as accurate you can get is plus or minus 10 meters. Okay, so essentially what it's using is it's using multiple satellites to triangulate the location of the receiver, and using that, the more satellites you have, the more accurate it can be. And it can be as accurate as centimeters precision. Another way of collecting geospatial data is with geocoding and databases. So this is a method of attaching spatial locations to a data set. So if you have an address like 6225 University Avenue, how do you know exactly where that is? Well, typically you're using this street, and each street, if it's ready for geocoding, will contain the numbers for each segment, and it will estimate its location along the segments of roads and whether it's on the even side or the odd side. So that's essentially what geocoding does. So it's most often done with addresses, but it can be done with any sort of locational information, even if it's just as far as a city or a postal code. The last way of collecting GIS data we're going to talk about is scanning and digitizing. So how do we get information from maps that were created long before GIS existed? Well, scanning and digitizing is going to help you bring that information into the digital world. Okay, so essentially it's how you create vector data, points, lines, and polygons from images. Okay, so these hard copy maps or maybe old aerial photography are scanned in, so that makes them digital. The next thing you need to do is georeference it. So you need to tell it where that image belongs in geographic space. Okay, and then finally, using either graphic packages or digitizing tablets, you're going to trace that information in that's on these maps or aerial photography. and that data can then be brought into a GIS. Next, we're going to speak about the types of GIS data there are. When using GIS, there are two main data types that you'll be looking into. You'll be dealing with either vector. So vector is data that deals with points, lines, or polygons. So this is common with a lot of topographic data, roads, contours, buildings, lakes, rivers, things like that. Raster data, on the other hand, uses pixels or arrays of cells to represent features on the Earth. This is most common if you look at satellite imagery, air photos, or scanned images. So here's a diagram of showing how data could be represented either in the vector data model or the raster data model. So you can see at the top is the vector data model, where everything would be represented either as points, lines, or polygons. And you can kind of get a sense of what's going on there. Below that, you can actually see how the same data could be represented as a raster data format. Okay, so you can see there's the points. In the case above, we have 3 points. In the image below, showing in raster, you'll have a series of cells, but 3 of those cells will have a different value within it. Okay, if you look over to the lines, you can see how the line is being represented as a series of pixels that are side by side or adjacent to kind of give you the sense of connectivity. But again, every pixel has to have a value, and sometimes it'll have a value of nothing or no data, or sometimes it would have a value of, in this case, the line. In the third example is showing you how a polygon would be represented in raster. So you can see here, again, you're seeing adjacent polygons representing the polygons that are shown above. So they need to be adjacent to give you that sense of a larger feature. So again, you can see there's a difference here. In this particular case, the raster might not look as good as the vector, but realize you can get a lot closer to matching the way something appears if I made smaller squares. Again, a lot of the data, as I mentioned before, like for instance, comes from aerial photography. Our forest inventories and our topographic maps all come from air photos or raster. So obviously they can never be more precise than the data from which they came. So think about that a little bit, and how when you think about which is better, vector or raster, it really depends on what the situation is and what you're doing. Next, we're going to talk about file formats. What exactly is a file format? So a file format is a mechanism on how the data is stored within a computer. It indicates to the system or the software where to look for various pieces of information. It's really important to know because not all GIS softwares will read all types of GIS formats. So what does a GIS format include? Well, it does have to include the geographic information. So where is the data located and what is its shape? Is it a point? Is it a line? Is it a polygon? Is it a raster data set? It also can include the attribute information, that additional non-spatial information or data. And the third thing it can include is the display information, how those features are going to be shown on screen. It's important to realize that not all formats will have all 3 types of information. Typically, they'll have 2 of the 3. So what vector formats will QGIS accept? Well, it'll accept GeoPackages, it will accept shapefiles, it will accept map info tab files. It will also accept delimited text files. So these are going to be point data sets where each column of information contains a separate bit of information. It will also accept well-known text or WKT. You can also use OpenStreetMap data and spatialite layers. So what about raster formats that QGIS will accept? Well, it can accept ArcGIS binary grids. It can accept ArcGIS ASCII grids. It can bring in GeoTIFFs as well as IRDAS Imagine. It's important to realize that QGIS uses an external GDAL library, so that must be installed in order for many of these formats to be able to be imported properly. Next, we're going to talk about coordinate systems and projections. Coordinate systems. They're also known as reference systems, and you need to know what the coordinate system is for the feature locations to be displayed properly. There are two main types. There is geographic and projected. So as I mentioned, there were two main types of coordinate systems. There's geographic, and this is locating objects on a curved surface. Their units are going to be in decimal degrees, so it's angular measurements essentially. The second main type is projected coordinate systems, and these are locating objects on flat surfaces like maps. A little more about geographic coordinate systems. They are always measured in latitude and longitude, and these are angular measurements that are from the center of the Earth out to the surface. So it's like having a protractor that you can bring to the center of the Earth and measuring off the amount of degrees. So again, latitude and longitude will typically be measured in degrees or decimal degrees. Projected coordinate systems, on the other hand, locate features using X and Y values, typically measured either in meters or sometimes in feet, from a point of origin. So in this particular case, it looks to be the equator and the prime meridian, but it doesn't have to be. Different projections can use different origins. So a quick comparison between the various types of coordinate systems. So geographic, use a network of intersecting lines called a graticule. It's measured in latitude and longitude. And this is an angular measurement from the Earth's center to a point on the surface. Measurements are typically expressed as degrees, minutes, seconds, or decimal degrees. And the goal is for locational accuracy. Projected coordinate systems, on the other hand, use an X and a Y axis. These latitude and longitude are converted or projected to planar coordinates. Locations are measured with an X and a Y value from a point of origin in a given unit, typically meters, sometimes feet. The goal is locational analysis to measure distance, calculate area, maybe calculate the shortest distance, for example. Just to add a little more depth to the coordinate system, you also need to be aware of the datum when you access data. So what is the datum? The Earth is not a perfect sphere. It's a spheroid, and actually it's a spheroid with lumps and bumps on it. But typically speaking, a spheroid is used to represent the shape of the Earth. And depending where you are in the world, there are different spheroids that typically tend to be used. So with the coordinate systems, the datum also needs to be specified, and this is going to be relating to which spheroid is being used to model the Earth's surface. All geographic datasets have a geographic coordinate system. Some datasets also have a projected coordinate system. Your datasets that you're using may or may not have the same coordinate system, but the software should be able to line them up, provided it knows which coordinate system your dataset is in. If you'd like to learn more about how coordinate systems look on the Earth's surface, take a look at https://projections.mgis.psu.edu. QGIS has what's called on-the-fly projection. This method of projection works as long as your datasets share the same datum. If not, there could be some slight misalignment. So this means you can bring your datasets in and they will automatically overlap each other regardless of the coordinate system you're using. So now that we learned a little bit about geospatial data and what sorts of things that are important in it, where do we go looking for it? Show me where the data is. So where can I find GIS data? Well, you can certainly talk to the ASCII GIS Centre. You can also go looking on municipal, provincial, and federal government websites. Private companies sometimes sell data, and as well as community groups and various organizations. So it never hurts to take a look at their webpage and or do some searches with the term GIS data. Scale issues. If you have many different data sources coming from different places, you could have many different scales. And basically this means the level of detail that was used to collect the data can differ. So if you're collecting data for the entire country versus for a province, how you would represent the shoreline, for instance, can be quite different. So just be aware of that. This is common and poses a challenge to interpretation on the analysis. Typically, you can still do analysis, but you do have to be careful of how you interpret that. So, what data do we have in the GIS Centre? The most commonly requested data is the HRM topographic data. So this is a scale that's as fine as 1 to 1000. We have the Nova Scotia topographic data. That's at a scale of 1 to 10,000. And just to be clear, that's the best scale data that we have that covers the entire province. Then we have data from DMTI, spatial data. This comes at a number of different scales and lots of different sorts of information that's there. Probably the most commonly used one there are postal codes. And Esri also has a number of different data sets, also available at a number of different scales, so we can help direct you towards those as well.
If you're looking for data from the GIS Centre, please feel free to browse our website at www.dal.ca/GIS. Some of our most commonly used data sets are also available for immediate download from our self-serve data extraction tool. You can find that at https://gis.library.dal.ca/data. If there's something that you can't find, particularly if it's local, please feel free to contact us at the GIS Centre at gis@dal.ca, and we'll see what we can do to help you out.
What are free sources of data that are out there? Let's take a look.
So where can I access some of these data sources? Well, there's a number of them out there. There's data warehouses. You can access things on the internet. You can contact the mapping organization that might have collected it, or you can collect your own.
If you're looking for some useful free online links for data, particularly locally to Atlantic Canada, you can go to a few different sources. Okay, so if you're looking for topographic data, so these be roads, coastlines, cities, etc. In Nova Scotia, you would go to https://nsgi.novascotia.ca/gdd. In New Brunswick, you would go to http://www.snb.ca/geoNB1/e/index-E.asp. In PEI, it would be http://www.gov.pe.ca/index.php3 ? number equals 77868. If you're looking for Nova Scotia natural resource data for forestry, it'd be https://novascotia.ca/natr/forestry/GIS. For geology in Nova Scotia, be https://natr/meb/download/gis-data-maps.asp. For Open Data Canada, they have lots of different data, maps, satellite, and tabular data. You can go to https://open.canada.ca/data/en/dataset. What happens if you're looking for data outside of our regional area? Okay, there's a number of locations you can go take a look at. Here are a couple that I found. NGDC is a great location for finding geophysical data, both elevation and bathymetry as well. The website's http://www.ngdc.noaa.gov. If you're looking for soils data for Canada, you can go to Agriculture Canada, their soils database, and the website is http://sis.agr.gc.ca/kansas/index.html. Natural Earth is a great location to get a number of physical and cultural and raster data at 3 different scales. To access that website, go to http://www.naturalearthdata.com.
So now that we've got a handle on the data, we're going to jump into our scenario. So we're planning on doing a sampling exercise in the Bay of Fundy, Gulf of Maine. We're asked to create maps showing what data has already been sampled. We would also like to have information about the depths of the water in the area so we know what type of equipment we'll need to bring with us. So the data that we're going to be looking for is the sampling data that's already been collected, bathymetry data or water depth data, as well as the coastal outlines so we can see where the coastlines are and the Canadian boundary is. So the first data set we're going to bring into QGIS is an ASCII data set, and this will contain our station data. So before we can bring it into Q, we need to actually access the data, okay? So to bring in text data into Q, the data can be in a couple of different formats. It can be either .csv, which is comma separated or comma delimited values, .txt, which is typically a tab delimited format, any other sort of delimited format, as well as WKT, which is well-known text format. So what I'd like you to do is go into your browser of choice and go to ed.marine-geo.canada.ca/index_e.php. And this is going to be the Government of Canada Expedition Database. Okay. Then you're going to go on the left-hand side and click on Station Information by Place Keyword or Bounding Coordinates and Type. So the first data set we're going to access is our sampling data set. So you can see here I've brought up my browser of choice, which is Google Chrome, and then I'm going to go search for, I'm going to go to the top and I'm going to search for http://ed.marine-geo.canada.ca/index_e.php, and then I'm going to hit enter. Okay, I'm going to choose the first one there, the Expedition Database. Then on the left-hand side here under Station Information, I'm going to click on Station Information by Place Keyword, Bounding Coordinates, and Type. Continuing on under Georegions, we're going to select the Bay of Fundy. Then you're going to go down to the bottom and click the Station Types for the chosen area button. In the next window, you're going to choose All Station Types, and you're going to click on View Station Type Detail. Then you're going to click on the Download to CSV, or comma separated value. So now we're back to the Expedition Database website. Here under Georegions, we're going to choose the Bay of Fundy. Okay, so you're going to select on that. We're going to go down to the bottom of the window and we're going to click on the Find Station Type for Chosen Area button and hit that. We move on to the next page. We would like all station types, so I'm going to check the button there. And then we're going to View Station Type Details, that button at the bottom. And it's going to open up what the data looks like. So you can see here are all of the records for the Bay of Fundy on this website. So you can see there's 2,722 of them. You can see here I have the button to download the file as a CSV, so I'm going to click on that, and you're going to notice that the file should start to download. So when you're using data you've downloaded, it's really good to take a look, particularly if it's an ASCII format that you can read. So we're going to open it up in WordPad or Excel, and you're going to take a look to see what information is there, if there's any additional information, what columns are of importance, do we have information about the projection, the datum that's being used, things like that. So now we're going to open this CSV file that we downloaded. You may still see it in the corner of your screen. If you don't, you need to go to your downloads folder. So that's what I'm doing. I'm going up here, the three dots, going to downloads, and here is the file that I just downloaded. So I'm going to click on that, and you can see by default it opens up in Excel. Okay, so let's take a look at the information we have here. So what you notice here is the first 3 rows of data is just extra information. It's at row 4 that you actually start getting the data that you're using. Okay, so this first 3 rows can be removed or ignored. We don't need them. The other thing you'll notice is row 5 here has some blank information. It's also good to know. You can scroll through here and take a look at what's in here. One of the things you'll notice here in column D is the datum. So you can see this is in a WGS 1984 datum. If we scroll along a little farther, you can see here there's a couple columns, O and P, that are station lat and station long. Okay, so this is latitude and longitude. These are in decimal degrees, so we'll be able to bring those in. So the most important things that we see about this file, the first 3 rows we don't need. Column 4 is where our data starts. We know which datum we're in, and we know that we're dealing with latitude and longitude, so it is geographic data. So all good things to bring in, as well as a bunch of other information that is important, so we can take a look at later on. So by looking at the data, what did we learn? We learned that the first 3 lines are extra information. We basically don't require it to be read in. Line 4 is where the headers are for the column names. Okay. Line 5 was an empty line. It contained no data in it, so we might have to be aware of that. And if we looked at our data, we noticed that column D, the 4th column that was opened in Excel, contains the datum, and most of those are WGS 1984. And that the positional data are in 2 columns called station lat and station long. So now that we have the data, we want to create a location for our QGIS project to exist. This is where the project and the data will ultimately be stored. So we're going to do this using the File Explorer application, and we're going to create a folder called lunchlistlearn_data_QGIS in a location that's known to you. Then we're going to open QGIS and create a QGIS project file. So the easiest way to do this is to click on your Windows Start icon and type in QGIS. You're going to pick QGIS Desktop 3. Whatever version you're using. Okay. When Q opens up, you're going to go to the Project tab, Save As, and go into the folder that we just created. Okay, and again, that's lunchlistlearn_data_QGIS. And then you're going to save the file as QGIS_data.QGZ.
Now that we have our first data set downloaded and we've looked at it, and so we've explored it a little bit, we're ready to bring it into the QGIS software. So how do you do that? Well, the first thing we're going to do is create a location where our project's going to live or exist. So to access that, we're going to go down to the File Explorer. We're going to go into the folder that we would like to create this project. So for me, I'm going to put it right in my downloads. I'm going to click on New. I'm going to make a new folder, and I'm going to call it Lunchless Learn _ data _ QGIS. Okay. So now we have a location, and we're going to start our new project inside of this folder. So I'm going to minimize that. I'm going to go down to the search window down here beside the Windows icon, and I'm going to type in QGIS. Okay. We're going to choose the desktop application. So you can see the version I'm running here is 3.40.11. It's the long-term stable release, so it's probably the most stable version that we currently have. Okay, so you can see here is the project, and what I'd like you to do now, I'm going to maximize that. I'm going to go to the project tab up here at the top left corner. I'm going to choose the Save As option. And then I'm going to go into that folder that I just created. So in my case, it's this Lunchless Learn Data QGIS. So I'm going to double click in there. And the file name I suggested giving it is QGIS _ data. And it's going to give it a .qgz extension by default. So I'm going to click the Save button here. And I have a new project. And you can see up here, it's called the QGIS Data project.
A couple things to understand about the QGIS screen. When you open the QGIS program, there are a series of tabs and buttons at the top of the screen. On either side of the window, there are panels. In the middle, to start, there's a news and a default template screen, but this is the area that when data is added, your map will appear. It's also important to realize that depending on what is selected, various buttons will be either available to you or grayed out. So it's something to be aware of when you're using the program. So depending on what you have on the map will depend what you're allowed to do with it. Now we're ready to add data to our QGIS project. Under Layer, you're going to choose Add Layer and Add Delimited Text Layer. It's going to open a new window. For your file name, you're going to find that data that you downloaded earlier. Under the layer name, this is going to be what it's called when it's brought into Q. I'd like you to call it Station Data. Notice there's no spaces here. It's usually easiest to avoid spaces. Under the file format, leave it at .csv or com to separated values. For the number of header lines to discard, I'd like you to put 3. So remember, when we open the file up in Excel, we notice those first 3 lines was basically just information, but not actual data. So we want to discard that. Under the geometry definition, we're going to choose point coordinates, and we're going to select station long as the X field. So longitude is always going to be your X field, and station lat for your Y field. For the geometry CRS or coordinate reference system, you're going to make sure it's set to EPSG 4326-WGS 84. And again, that's information that we pulled out of the table when we looked at it. Then click the Add button.
Now we're going to add the data into our project. To do that, we're going to go up here to the Layer option, the Add Layer, and we're going to choose Add Delimited Text Layer. That brings up a pop-up. So for our file name, we're going to choose the name of the file that we downloaded. Okay, so you can see there, I've picked my file. For the layer name, this is what it's going to be called within our project. So I'm suggesting you get rid of that and just call it Station Data. Okay, again, no spaces or anything like that. You can see the file format, we're going to leave it at CSV. In our records and fields, Okay, we're going to expand that, and it says the number of header lines to discard. So if you remember, the first three rows of our data basically had some extra informational data, so we don't want to read that in as data. Okay, then we're going to expand the geometry attributes down here. We're going to make sure point coordinates is selected. For our X field, we are going to go ahead and choose our station long. For our Y field, it's going to be station lat. Okay. Then we're going to make sure that our projection is set to the default, which is the 4326. Okay. And it's WGS 84. Then we're going to go ahead and click on the Add button at the bottom of the window. Okay. Then we can close out of the window up here in the upper right corner. And you can see we have a number of points on our map. We can now see the CSV data as points on our map. But this is only a temporary visualization. It only exists in your computer's memory. In order to make it a permanent geospatial layer, we need to export it out to a new file. So how do you do that? You're going to right-click on Station Data in the Layers window on the left-hand side. This is going to bring up a pop-up. You're going to choose Export Save Features As. This is going to bring a new window into the center of your screen. You're going to choose the format as a GeoPackage, and then you're going to, for the file name, you're going to browse to the location of that folder we just created called lunchlesslearn_data_QGIS. Okay, because ultimately we want to keep all of our stuff together into that one folder. I'd like you to call it Station Data, and then you can click the OK button. This is going to create a brand new file that will also appear in the Layers window. So we want to remove our original station data. So you do that by right-clicking on the bottom station data in the Layers window and choose Remove Layer. So we can now see these points on our map, our station data. Ultimately though, these are just in memory. Okay, we want to make it a permanent format. So how do we do that? In the Layers panel over here on the left-hand side, we're going to right-click. Okay, we're going to go down to Export and Save Features As. In this pop-up window that appears, the format, we want it to be GeoPackage. Okay, the file name, what do we want to call this new file that we're creating? We want to call it Station Data. You can see it's maintaining the reference system here as WGS 1984. So this is the which we ended up getting from the information, okay? And it's pulling it out from what we told it originally. Then we're going to click the OK button. You can see what's happened is the file has changed colors for me just slightly to a darker color. But ultimately we don't need two versions of this file, okay? So one is virtual and one is actually a new file. So we're going to get rid of the bottom file. So just to be clear, we're not actually deleting it completely, we're just removing it out of the project. So to do that, we're going to right click and we're going to choose Remove Layer. It's getting us to verify that, so that's fine. And you can see now we only have one layer that's there, and we can turn that on or off.
So take a look at the data that you're seeing on your screen. Does it look like you'd expect it to? Not really. The shape doesn't look familiar. It appears to go northward in a straight line. So what I'd like you to do is pan around the screen and then look at the coordinates at the bottom of the screen. Do they make sense? Remember, the maximum latitude that you can go is 90 degrees north. The most southern direction you can go is minus 90 degrees north. And east and west, it's either from minus 180 to positive 180. So if it's take a look and see if the ranges make some sense there. When you're done, I'd like you to zoom in on the southern extent of your data and take a look there. So obviously, by looking at this data, hopefully you'll agree there's some bad data in here.
Does this look like you're expecting? Does it look like the Bay of Fundy? Well, hopefully you agree it really doesn't. So we have what appears to be a bunch of points down here and then some points that go straight upward. Okay, so it doesn't look what we're expecting. But let's take a look down here in the coordinates. Okay, so the first coordinate is to show how far north or south you're going. So you can see it's at 48 degrees. Okay, so if we go straight up, you'll see the number is increasing. The first number. If we go left or right, you can see that the second number is changing. Okay, so if you remember, our latitudes have a maximum value of 90 degrees. Okay, so we're going to start here and we're somewhere around 46, 47, 48, and we're going to scroll up, and all of a sudden we go, this little bit here takes us to 87 degrees north, and then we still have all these points that are going way north. Okay, so we obviously have some bad data in here. Okay, so what I'd like you to do is focus on this clump of points down here. Okay, so I'm going to pan my data in, and then I'm going to zoom in. Okay, so I'm just using my center roller button. You can use the buttons up here if that's easier for you. Okay, so when we take a look here, this is looking maybe a little bit more like we were expecting. Okay, because this here is Nova Scotia, this would be New Brunswick, and this is the Bay of Fundy and the Minas Basin. Okay, so this is a little bit more what we're expecting. So obviously we had some bad data points in there, but we're going to focus on the ones to the south.
Next, I'm going to show you how to change the color or the symbology of the station data. To do this, you're going to right-click on Station Data in the Layers window on the left-hand side of your page. It's going to bring up a pop-up. You're going to choose Properties and Symbology. To change the color, click on the patch next to the color, and then select the color you would like, and click the Apply button, and then close. If you'd like to change the symbol, you can click on the Simple marker, then go down to the bottom of the window and select the symbol that you'd like to see. Adjust any of the other parameters you would like to see, color or whatever. Then you can click the Apply and Close buttons.
What happens if you want to change the symbology that we're seeing on our map? Well, to do that, we're going to right-click on our layer in the Layers panel over here on the left-hand side. In the pop-up, we're going to go down to Properties. Okay. Then we're going to make sure that our option is Symbology. And if you want to adjust the color, it's actually super easy. You're just going to click on the color patch. And then you can choose to change your color either by clicking in here or adjusting your numbers over here, or using the various other options that you can pick from. So maybe this time I'll pick kind of a maybe a more yellowy color. And if I'm happy with that, I can click OK. If I want to adjust the size, maybe I'll make it a little bit smaller. Okay, and you can see this is 1.4 millimeters, and then I'm going to click the OK button, and you can see I now have these gold colored points on our map. If on the other hand I don't want these little circles, I can also change that. Again, you can go to right click on your layer in the Layers panel, go to Properties, and you can see down here we have a number of different styles of maps. Okay, you can choose from favorites to maybe all symbols, to all symbols, and you can adjust whichever one of these you want. Okay, so again, so you know, maybe you want red diamonds. Okay, but again, this one's a little bit large for me, so I'm going to make it 1.6 maybe, just make it little, and I'll say okay. So now I have red diamonds showing as my points. Next, we want to add a coastline to give us some additional context to where things are on our map. So where are we going to find that data? Well, you're going to open up your browser of choice and then go to https://natural-resources.canada.ca/. science-data/science-research/geomatics/downloads-directory-documentation.
Once you find the right page, I'd like you to scroll down to the archived collections. So that's going to be under the Atlas of Canada 1 million National Framework Data. Under that, you're going to choose the administrative boundaries. This is going to open a new window, and you're going to click on the 1m_boundary_2008.arc.shape.zip. This is going to download the data for you. You're going to move the zipped data into your lunchless learn_data_QGIS folder using the File Explorer.
Now that we have the station data in, we're going to add some additional context to our map. So what we're going to do is we're going to add the coastline in here. So to do that, we're going to go to our browser of choice. For me, that's Chrome. I'm going to open up a brand new tab, and I'm going to type in the address. Okay. So again, that is natural-resources.canada.ca/science-data/science-research/geomatics/downloads-directory-documentation. For those of you doing this with us during the Teams exercise, I'll put this address into the chat and you can just download it from there. So what we're going to do is we're going to scroll down until we hit the archive data. So there's our archive collections. And we're going to go to the Atlas of Canada 1 million framework, specifically the administrative boundaries. So I'm going to click on that. And then we're going to click on the first, the 1m_boundary_2008.arc. So that's the 1 million scale boundary. And you can see that it's downloaded into our folder. So I'm going to go into our folder. So I'm going to minimize that. I'm going to go into the File Explorer, and you can see there's the file that we downloaded. We're going to put that inside of our Lunchless Learn data folder, just to keep everything together, okay? We want everything from our project in that same folder, okay? So you can see in the File Explorer, I just dragged and dropped.
A quick word about zipped files. File zipping is a way of compressing multiple files into a single file. It's typically going to make the files smaller and easier to move around. When using zip files in some programs, you need to uncompress or unzip the files before they can be used. This is not the case with QGIS. You can leave them zipped up. As to unzipping or zipping your data, depending where you are on campus and what software you have, there may be different programs that you can use. So again, just be aware of that. Now we're ready to bring the coastline data into QGIS. To do this, you're going to go to the Layer tab at the top of the screen, Add Layer, Add Vector Layer. In the new window that appears at the Source Vector Layers, use the ellipse button and choose the file we just downloaded, 1m_boundary_2008.arc.shape.zip. Then click the Add button and then close the window. Then zoom in and or pan to see the Bay of Fundy area.
Now that we have everything in the same folder, I'm going to minimize our File Explorer. I'm going to go back up here into our Layers folder. I'm going to go Add Layer, and we're going to add a vector layer. Okay. Then what we're going to do is we're going to browse to our source. Okay, so we're going to use the Browse button over here, and we're going to go inside of our Lunchless Learn folder, and there's our 1m_boundary_2008.arc.shape.zip file. We're going to select it, and then we're going to click on the Add button down here at the bottom. Okay, then we can close out of our window. You can see that the coastline has been added, and you can see, in fact, those points were in the Bay of Fundy area.
Next, we're going to change the symbol of the coastline. To do this, you're going to right-click on the coastline layer in the layer window. It's going to bring up a pop-up, choose symbology, and then click on the color patch and choose the color that you would like the coastline to be.
So you can see we have the coastline in, but if you want to change the color of it, how you do that is you go over here to your layers panel on the left side. You're going to right click on the boundary layer. You're going to go down to the bottom to the properties, and you're going to make sure you're on the symbology option here on the side, and you can change the color of the line by clicking on the color. And you can choose to use RGB or hue saturation value, or you can use one of these other options here. So for me, I'm just going to go ahead and I'm going to pick a black option here. And then I'm going to click on the OK button and then OK again. And you can see now I have a black coastline.
So now, based on our scenario, we have 2 of our 3 data sets in. Next, we're going to access the 3rd data set. And this is going to be a raster data set. So bathymetry data is also known as depth of water, and it's typically represented either as contours or as a grid. The data we're going to be accessing today will be in the grid format. So to access the data, I'd like you to open a browser and go to http://www.ngdc.noaa.gov/mgg/image/2minrelief.html. So when you get to that web page, you're going to go and click on the latest global relief model. Then, under Grid Extract section, click the Launch Grid Extract button. This is going to open a brand new page. At the top of the page, select the dataset as eTopo_2022 Bedrock 60 arc seconds. Then click on the box next to the area of interest. This is going to bring up a pop-up on your screen where you can input the area that we're interested in. So the northern extent should be 47, the southern extent 40, the western extent -70, the eastern extent -58. Then click the Save Changes button. Then click on the Download Data button and your data will begin downloading.
Now we have 2 of the 3 data sets in our map. We're going to now access the 3rd. To do that, we're going to go to our browser of choice. For me, again, that's Chrome. We're going to open up a new tab and we're going to type in the address. Okay. So again, that's https://ngdc.noaa.gov/mgg/image/2minrelief.html. And then we're going to go just under the image and click on the latest global relief model. We're going to scroll down a little bit. Under the Grid Extract, we're going to click on the Launch Grid Extract button. So now what we need to do is select our data set. What we're looking for is the eTopo 2022 Bedrock 60 arc second. So you can see there's finer resolutions, but for speed's sake and for the area size we're dealing with, we're going to pick the 60 arc second. Okay, so we've selected our data set. Now we need to select our area. So I'm going to click on the button. And you can see here we get to enter our coordinates. So our northern coordinate is 47. Our southern coordinate is 40. Our western coordinate is -70. And our eastern coordinate is -58. It's really important for your eastern and western coordinates to have negative values. Again, this is because it's west of Greenwich Mean, which is in England, so we need the negative values. Okay, so I'm going to click on the Save Changes button, and you can see our area highlighted here. You can see I purposely went a little larger than the Bay of Fundy, just so we have some extra context there. Okay, Then we're going to click on the Download Data button, and you can see that it's automatically downloaded into our Downloads folder.
So now that we've downloaded the file, we want to move the raster data into our project folder with the rest of our data. So using the File Explorer, you're going to move the raster, which by default should be called exportimage.tif, into the folder that we created at the beginning of the Lunchless Learn, and that's lunchlesslearn_data_QGIS. Once you've moved it, we're going to add that raster data into our map. So to do that, you're going to go back to your QGIS window. You're going to go back up to the Layers tab again and click Add Raster Layer. In the window that opens, choose Raster Dataset, use the ellipse button, and browse to our exportimage.tif file. Click the Add button, then Close to get rid of the window.
We've now downloaded the third data set. So what we're going to do here is we're going to minimize our Chrome browser. We're going to go into our File Explorer. There's our export image. Again, to keep all of our project data together, we're going to put it inside of this Lunchless Learn data folder. So again, I'm just going to click it and drag it into that folder. I'm going to minimize that window, and then we're going to go back to QGIS, and we're going to go to the Layers tab up here at the top. We're going to go to Add Layer, but this time we're going to be adding a raster layer. Okay, we're going to use the ellipse button here. We're going to go browse for our file, and you can see there it is, the export image, and I'm going to choose the open because by default it's automatically gone to the same place where we opened before. So then we're going to click the open button and then click on the add. And then we can click on close down here or the X button. Either or is fine. So you can see here that our image has now appeared on top of our existing map.
Next, we're going to talk about changing the order of the layers. In order to see all of the information on your map properly, you need to adjust the order of the layers that appear on it. So the best way to do this is to show the point layers at the top, followed by the line layers, and then polygons. At the very bottom, if you have them, you should have raster files. Otherwise, the order that it appears in your list is how it's drawn on the map. So if you have your raster layer on top, you can't see any of the other data that's underneath it. Okay? So in order to change the layers so that they make the most sense, you're going to select the layer of interest that you're going to move up or down in the Layers window, and then drag it up or down as you see fit.
You can see when the raster data came in, it came in over top of the other layers. So remember, the order that things appear in your Layers window is the order they appear on the map. So in this case, the raster image is on top of the other two layers. And if we want to put it underneath, we can actually just click on it and drag it underneath the other two layers. Okay, so in this case, you can see the lines are actually on top, followed by the points, followed by the image. Again, if for instance there was a place where the lines and the points overlap, maybe you want to in fact drag the points above the lines. Maybe that makes more sense. But again, having it make the most sense definitely means having the raster on the bottom so you can see the other two layers.
So now we'd like to change the color of our raster data that we're seeing. So to do that, you're going to right-click on Export Image in the Layers window on the left side. This is going to bring up a pop-up. Choose Properties and then Symbology. Change the render type to single band pseudocolor and then select the color ramp of choice. Click OK and then close the button. If you want to get a little more advanced, you can adjust the way the color is ramped by adjusting the parameters in the min and max. I would suggest making the minimum value -500 and the maximum value 150. See what that does to your map.
You want to change this elevation data or bathymetry data to something other than grayscale. So again, how do we do that? Very similar to changing symbology as we did before. You're going to right click on the layer name. You're going to go to the properties option. You're going to make sure you're in symbology. This time you want to go up here to the render type and you're going to change it to a single band pseudo color. Okay. Next, you're going to want to choose your color ramp. Okay, so I'm going to use the drop down here and I'm going to pick a color ramp. So in this case, maybe I'll pick the spectral. And then I can click the apply button. And when you click the apply button, I'm going to move this out of the way. You can see it automatically gets applied to your screen here. Okay, so this is great, but what we're noticing actually is intuitively the red is in the deep and the blue is at the highest. So we kind of want to flip that around. So how do you do that? So again, we're going to go to this color ramp button here on the side and we're going to choose the invert color ramp. Then we're going to click the apply button down here again and you can see automatically that this has flipped the color. So red is at the highest, blue is at the lowest. Okay, but you can see it's still not great. We want to kind of get our colors, because right now it's being spread over such a large scheme. So what we want to do is adjust the range that these colors are being adjusted over. So what we want to do is we want to change the minimum and the maximum value up here. So I'm suggesting for the minimum value you put in -500. And for the maximum value, I want you to put in 150 and then click the apply button again. So you can see what's happened now is anything that's lower or deeper than -500 meters gets the darkest blue color, and anything that gets higher than 150 meters positive gets the red. Okay, so you can see that that's done pretty well. It actually really highlights the banks out here on the continental shelf. So that's great, but you'll notice now what's happened is now my points don't show up well. So now that I'm happy with the symbology for this, I'm just going to close out of it and I'm going to adjust my station data because again now that's kind of getting mushed in here. So I'm going to click on my station data. I'm going to right click, I'm going to choose properties, same as I did before, and I'm going to change the color. So this time maybe I'm going to change my point color to maybe a really dark blue, and then I'm going to say OK, and then OK again. So you can see now that it shows up really well, the points. And if I want to investigate what is going on my map, I can use this button up here, the identify features. So that's the blue circle with the white eye in it. I'm going to select on that and I'm going to click somewhere on my map. So again, if I click on the land, then what I'm going to get is oh, and then I also have to pick the layer that I'm interested in, pardon me. So in this case, I'm going to pick on the export image, and then I'm going to click on my point. And you can see here that the value there is 331.9. In this case, it's meters. So if I click on something out in the ocean, okay, you can see that the value now is a negative value, -102.5. If, on the other hand, I want to investigate what these points are, I'm going to select on the layer in the layer file over here. So in this case, I'll pick the station data, and then I'm going to pick one of the points in the Bay of Fundy. And then you can see all of the information that we have on this particular point. You can see that it was collected from the Baffin. You can get some information about the type of grab it was. It was a Van Veen grab, and you can see some other information about it. Okay. If, on the other hand, you want to get information about the coastline, again, just make sure you're selected on the coast in the layers option, and then select on the piece of coastline. So you can see here it does say it's coast. If, on the other hand, I pick on this line that's out into the ocean, you can see this is the EEZ, okay, or the exclusive economic zone. So again, any of the information you can get by clicking on your map, by clicking on the identify button and selecting the layer you want to identify.
Now we're ready to save our QGIS project. Okay, so we're going to save the QGIS project, which has that .qgz extension. Be aware of what it's actually saving. It's going to save the location of the data or layers. Note, it's saving the location, not the data itself, which is why we were very conscious to put our data sets inside the same folder. Okay. It also saves the view area that we were looking at, any bookmarks had we had them. It will also save how the data looks, so it's symbology. And if we had created a final map, it would have saved that as well. To save the QGIS project, go to the Project tab in your QGIS window and choose the Save button. Okay. The file is going to save in the folder where you originally created it. If you want to move your file to a different machine, you're going to want to move the entire folder. Okay. So that's not only the QGIS, but everything else that we've put in there. A hint, if you're going to be moving your data from machine to machine, it's a good idea to zip up the folder. Then you only have to zip one file and you don't have to worry about missing files.
So now we've added all of our data sets and we're done with the project for now. So how do you save it? Again, remember when we created this project initially, we did save a file called QGIS Data. Okay, so we're just going to save over top of that. So again, you can do that by going to the project and the save option. Okay, or you can do this quick save option up here. So what's really important now is if you're going to be moving this data or using it to use it again later on, you want to make sure we've been very deliberate in putting everything inside of that project folder. Again, remember that it was called the lunchless learn underscore data underscore QGIS. So we put everything in that folder. Okay, so when we save the project, it saves that .qgz, but that only points to the data. So if we don't save the data as well in a known location, then it won't be able to find it. Okay, so again, everything stays in that folder, and ideally you would just zip that up and move it from place to place depending on the next time you're going to be using it, whether on your machine or on somebody else's machine.
A couple more tips to think about. If you can't find the data you're looking for, you can collect your own. You can use GPS to collect your data locations. You can go online and see what data is available there. You can use tabular data if you find it, or some combination of all of these options. So some tips for importing XY data. You do need a minimum of 2 columns for your coordinates. Can be X and Y, can be northing and easting, or it can be latitude and longitude. The names themselves are not really important, but those would be the common ones. You can keep or add additional fields. And typically when you save the file format, you're going to save it as a .csv or comma separated value, or a .txt, which if you're using Excel is a tab delimited format. And here's a quote by Jack Dangerman. He's president of Esri. This is the company that creates ArcGIS Pro, which is a corporate paid for GIS, probably the biggest one in the world. But regardless, this quote actually is meaningful regardless. The application of GIS is limited only by the imagination of those who use it. So although it was quite a bit of work and we're kind of fumbling between a few different softwares today, remember, it can be really worth it, and you can do a whole lot of things with GIS.
Thanks for coming to our session. I hope you found it useful. If you're looking for more information about us at the GIS Centre, we are located on the 5th floor of the Killam Library behind Special Collections. Again, my name is Jennifer Strang, and I can be reached at jennifer.strang@dal.ca, or you can give me a call at 902-494-1386. Feel free to book an appointment with any of us here at the Centre. You can go to www.dal.ca/GIS and look for the book an appointment link. Thanks.